Hello again, math students. This is our last lesson in the Pythagorean theorem. The next lesson is going to be our review, and then we'll be taking our test. So today what we're going to work on is just still more applications of the Pythagorean theorem, but we're going to be looking at some multi-step problems. So when I have a triangle like this, I have two right triangles really involved, because if we have a right angle here, we also have a right angle here. So the triangle that's on the left is a right triangle, triangle on the right is a right triangle. Together they make up a bigger triangle. I want to be able to find any of the missing lengths that are in here. So for instance, in the triangle on the left, I know that my legs are 1 and 3, right? And those have to be the legs. They make the right angle. So I would have 1 squared plus 3 squared equals c squared. So 1 plus 9, and that's going to be 10. But again, I don't want c squared. I just want c, so I would take the square root. Remember, we don't really need the negative answer here, but the square root of 10 would be, I guess I should have put the c first, about 3.2 when we round this. So this side is 3.2 units, whatever those happen to be. The other part that I need is this side right here. Now the trick, as always, is making sure that we've got the c in the right place. The 5 in this case is the hypotenuse. It's not touching the right angle. It's across from the right angle. That's got to be the c. So this side that's missing, we can call this A or B or whatever. I guess in this first one, I could have labeled that this one was C. When you do your learning check today, I'll have variables. I won't put A, B, or C. It'll be like X or Y, so that you know which part you're answering first. So to find A, I would do A squared plus 3 squared equals 5 squared. And by now, you could probably just about do this in your sleep. Also, before we finish this, I'm hoping that some of you are recognizing the Pythagorean triple that's going to be coming in here. 25 minus 9 is going to be 16. And when we take the square root on both of those, I'll get that A is 4. So this is 4 units long. Now, the application that you could use as the next step, we're not doing this, but we could use this to find the area of that original triangle. Remember, area is 1/2 times base times height. I didn't know the base. The 3.2 wouldn't matter in terms of the area of this, but now I would know that the full base of this triangle is actually 5 units long, and it's 3 units tall, so I do 5 times 3 and then divide by 2, so it'd be 7.5 square units. That's not the part that we're doing today. Today, I am only concerned about finding these different measurements. So in this problem, again, on the left triangle first, I guess, this is the C, right? That's the hypotenuse. So I am missing on this base right here, either the A or the B. I've already mentioned this. I really prefer to have it as an A just because my equation looks nicer that way. So I would have A squared plus 6 squared equals 11 squared. So that'll be 36 and 121. And we'll get rid of the 36. So 121 minus 36 is going to be 85. Not a perfect square. But again, you should be able to get an idea of about what this answer should be. This is going to be a little bit more than 9, right? So A is going to be about, the square root of that answer is 9.2 when we're rounding to the nearest tenth. So this side length would be 9.2. In the right side of the triangle, I have the 2 legs. I'm looking for this, which happens to be the hypotenuse. That's going to be the C. So I'll have 5 and 6 are my legs. 25 and 36. And when we add that, we should get 61. And then we'll take the square root. So the square root of 61 is going to be about 7.8. Let me move where that C is because I want to put my answer on the outside. And again, just the basics I know, but this is also a good check. Make sure that your hypotenuse is bigger than the legs. If you had gotten an answer like 4 something, like if you had mistakenly used the 6 as the hypotenuse, that's something you have to watch out for. Okay, in this triangle, we have on the left side, I guess it doesn't really matter which side you do first. I'm just used to doing the one on the left side first. And again, remember, I do have a right angle here. I have a 6 and an 8. This side that I'm looking for is the C. Again, some of you may already know what this answer is going to be, but I'll have 6 squared plus 8 squared equals C squared. That was a really bad 2, I'm sorry. 36 plus 64 equals C squared, and that's 100. So then the hypotenuse is 10. This is a 3, 4, 5 triangle, but doubled. So it's twice as big. So instead of a 3, 4, 5, it's a 6, 8, 10. Not that you need to know that or recognize that, but it just does kind of help sometimes. In the right triangle, the side that's missing is one of the legs. It's touching the right angle. Again, I'm going to just call that an A. So I'll have A squared plus 8 squared equals 11 squared. And then we'll get rid of our 64. So 121 minus 64 is going to be 57. Again, not a perfect square. So when we take the square root, we're going to have to round. The square root of 57 is 7.5. That'll round to. I'm hoping that you're feeling like this is not a big stretch. This is just another application, just a little bit of an extension from what we have been doing. These are not going to give us any kind of a Pythagorean triple. We're not going to have nice whole number answers on this problem. So on the left triangle, if I'm looking for this, it will be the C again. So the 8 and the 4 are my legs. 8 squared plus 4 squared equals C squared. 64 plus 16. So that would be 80. Now, if that had been 81, we would have gotten 9 exactly. So when I take the square root of this, it should be just a little bit less than 9. I've got 8.94, so it almost rounded up to 9, but it's going to be that the hypotenuse is about 8.9. And to find this missing leg right here, again, I'm going to call that an A. So I've got A squared plus 4 squared equals 7 squared. When we get rid of our 16, that would be 33. And again, the square root of 33, you should be able to get an approximation. You know it's going to be between 5 and 6, I hope. That is going to be 5.7. So today's worksheet problems just like that. There'll be 2 pieces that are missing in each triangle. So you have to find both of those using the Pythagorean theorem. Again, the one thing you have to watch out for is make sure that you've got the right number in place of the hypotenuse. And then there is the answer key in Schoology. The learning check is going to look just like these. But like I said, I already labeled the missing pieces with X and Y, so you know which one you have to put in for which answer. But there's nothing more tricky about this, in my opinion. If you need help with any of this, let me know. Remember, we're coming up on the end of the chapter now. So if there's any part of this whole chapter that's been a struggle for you, please talk to me before we take the test this week. Good luck.